Okay, so in the last lecture, we have been talking about the known quantities. First, we have talked about the classification, and then we have started looking into the equations. So, these are the equations for the known quantities corresponding to the power injection. Please note here, here is I is actually P is A, B, C, and I is 1, right? So, for each of this original n bus and for each of this phase. So, this is for real power, this is for reactive power. Now, let us look at the equation for, so these are the equations for real and reactive power. So, now let us look at the equation for generator real power. So, if I say that my PGI, now what would be my PGI? So, we have to write down the expression of PGI. So, what would be PGI? Now, what is PGI? We said that PGI is the generated real power by the generator located at bus I. Now, what we here assume is that once we have assumed an internal bus, please note, I again repeat that this internal bus doesn't exist physically, it is our simply a kind of mathematical artifact or rather kind of a virtual bus which is invented or rather which is considered for the ease of our calculation. So, this PGI, so then therefore, when we have considered the generator internal bus, mentally what we are actually shifting, we are actually shifting the generator from the original bus to its internal bus. So, then therefore, for example, if I have an bus I and if I have a generator connected at bus I in my original system, and then we consider an internal bus. So, this is bus I, and then in between bus I, so this is an internal bus. So, this is bus n plus I, right? And we say that this generator is now connected here. That's what we say. And this is the 3 cross 3 matrix, and how to get this matrix, that also we have discussed. So, then therefore, we are not repeating it. Now, we said that this matrix is actually composed of, essentially this matrix is essentially derived from the knowledge of the generator positive sequence, negative sequence as well as the zero sequence reactances, impedances are actually reactances. Now, here we are assuming that the generator internal resistances are actually basically it is totally negligible, it is mostly reactive. So, then therefore, this impedance is nothing but a matrix which is only representing the reactances. So, then therefore, as a result, the total real power generated at this bus would be ultimately proceeding to actually bus I without any loss in between. For example, if I say that originally this bus, this generator is generating say 100 megawatt. So, what we are saying now, because we have now shifted this now because we have now shifted this generator at this internal bus, so we are saying that it is basically pushing 100 megawatt at this bus. But our original specification was that this 100 megawatt is actually going to bus I. But then this doesn't pose any problem because of this, that this 3 cross 3 impedance matrix is essentially a 3 cross 3 reactance matrix, because we have considered the generator resistance to be negligible. So, then therefore, as this is a reactance matrix, so then therefore, in this path between n plus I to I, there will be no real power loss. Because there will be no real power loss, so then therefore we can safely assume that this 100 megawatt will ultimately reach at bus I also. So then therefore validating our original specification. So for our calculation, when I say that that any particular generator is actually generating total say 100 megawatt, what we say is essentially we are saying that this generator is now shifted at the internal bus, and now this total generator is actually now at the internal bus. So then therefore now please note that this 100 megawatt is actually the sum total of the power generated by all three phases. So then therefore PGI would be nothing but the sum total of the generated power at phase A of n plus ith bus, as well as at phase B of n plus ith bus, as well as at phase C of n plus ith bus. So then therefore I can write down that PGI is nothing but P n plus I A plus P n plus I B plus P n plus I C. Right. So what is P n plus I A? P n plus I A is the injected real power, because it is a generator. So then therefore the actual generated real power would be equal to the injected real power. So then this injected real power at bus n plus I, that is the internal bus corresponding to phase A, plus the injected real power at n plus ith bus corresponding to phase B, plus the injected real power at n plus ith bus corresponding to phase C. And the expressions of Pn plus Ia, Pn plus Ib and Pn plus Ic would be exactly the essentially same by this expression PIP, right. So all these expressions would be calculated. So all these expressions they would be calculated by the expressions of injected real power, right. So if I say that this is equation 1 and if I say that equation 2, so then therefore I can say that all these would be calculated by equation 1, calculated by equation 1. Right. So then therefore now let us see one thing. Now basically by using this equation, let us try to write down the equation of PGI, or rather let us now try to derive the equation for PGI. So now by using equation 1, what is Pn plus Ia? So from equation 1, Pn plus Ia is, from equation 1, Pn plus Ia. What would be Pn plus Ia? That would be L is equal to A, B, C, then J is equal to 1 to N plus M, then V N plus IA, V J L, Y N plus I J A L cosine theta N plus I A minus theta J L minus alpha N plus I J A So that is the expression. Just in equation 1, if I put I is equal to n plus I and p is equal to a, I get this. Now here we have to take into account one very interesting fact. From this diagram, because it is an internal bus, n plus ith bus is directly connected to only ith bus. It is not directly connected to any other bus. So then therefore, in the y bus matrix, there will be no element between n plus ith bus and any other bus corresponding to um, basically so then therefore I mean let us write it. So in the y bus matrix, now let us write it. Now n plus ith bus is directly connected to only bus I. So therefore, in the y bus matrix, the entries corresponding to n plus ith bus and bus j and any bus j. And what is the condition of j? J is from 1 to n plus m, and j is not equal to I, right? For any j which is not equal to I, so the entries corresponding to n plus ith bus and any bus j would be 0, because there is no direct connection. So then therefore, even when this j would be varying from I to n plus m, or rather I mean even when this j would be varying from j is equal to 1 to n plus m, only the entries corresponding to j is equal to I and j is equal to n plus I, they would be there. Other quantities will not be there. So this we must understand, right? So other quantities will not be there, right? So then therefore I can say that it will only work for j is equal to I, because n plus ith bus is directly connected to ith bus. So then therefore there will be some element between n plus I and I. So then therefore y n plus I would be an non-zero matrix, and of course when j is equal to n plus I, that also would be there, correct? So then therefore I can say, so therefore thus I can say that p n plus I a is actually only L is equal to A, B, C, and J is only I and n plus I, nothing else. J is only I and n plus I, nothing else, right? Because if J is anything else, it would be just 0. So it would be V n plus IA, V J L, Y n plus I, J A L, then we have cosine theta m plus ia minus theta jl minus alpha n plus I j a l. This is the, so then therefore here there will be only 6 entries. When I am saying 6 entries, so I am constituting that this is one single entry, that is this entire multiplication is one single entry, right? So when this is a, so when L is equal to a, I is equal to uh, and basically when L is equal to a, j is equal to I, L is equal to b, j is equal to I, L is equal to c, j is equal to I, and then L is equal to a, j is equal to n plus I, L is equal to b, j is equal to n plus I, and it is L is equal to c, j is equal to n plus I. Only these 6 cases would be keep on adding each other, right? No other element would be there. Similarly, I can write down, similarly, I can write down Similarly, I can write down that p n plus I b is actually L is equal to a, b, c. Then j is equal to I and n plus I. J can only have these two values, I and n plus I, because if j is any other value, it would be always 0. And this is v n plus I b, v j l, then y n plus I, comma j b l, then cosine theta m plus I b minus theta j l minus alpha m plus I j b l, right? Now I say that this is my equation 3. Now we can do a little bit more. Now I understand, and now we know also that v n plus I a is equal to v n plus I b is equal to v n plus I c, right? So then therefore this I can write down as p n plus I b is equal to L is equal to a b c, and then j is equal to I n plus I, then Vn plus Ib is equal to essentially Vn plus Ia, because these are internal bus voltage which is considered to be balanced. Then Vjl Yn plus I j Bl cosine. Here also we can say that this is theta n plus I a minus 2 pi by 3, then minus theta jl minus alpha n plus I j b l. Why you have written this? Because we know that theta n plus I b is equal to theta n plus I a minus 2 pi by 3 radian. And we also note that theta n plus I c is equal to theta n plus I a plus 2 pi by 3. Correct? So then therefore we say that this is bus 4. This is equation 4, correct? And by the same logic, we will just now and further p n plus I c would be L A B C, J would be only I and n plus I, then V n plus I c, right? So here originally it should be V n plus I c, but V n plus I c is V n plus I a. So I write V n plus I a, then V j L, then Y n plus I j C L cosine theta n plus I c is nothing but theta n plus I a plus 2 pi by 3 minus theta j L minus alpha n plus I j C L. So I should write it more. Theta n plus I a plus theta plus 2 pi by 3. Please note that this is nothing but theta n plus I c. So this is equation 5. And so then therefore PGI would be equal to equation 3 plus equation 4 plus equation 5. So this is PGI. So by adding this expression, and this expression, I will get the total expression. Although this is looking pretty, long, well, we will also see that how to, tackle it further. So, these are the expressions, and we will have to work with these expressions. So, the last one is remaining is that the equation for pre-specified voltage magnitude. So, the last is equation for, this equation is very simple actually, pre-specified voltage magnitude. Now, what these voltage magnitudes? These pre-specified voltage magnitudes at generator terminal. Right. So, we have got equations for pre-specified voltage magnitudes at generator terminal. Now, we need to understand something. In the case of balanced load flow, we take only one single value, say let's say 1.01 per unit. We do not at all talk about whether it is phase A or phase B or phase C, because it is a balanced operation. So all the voltage magnitudes are same. So then therefore, if we know that what is the voltage, pre-specified voltage at which the generator field winding is trying to maintain the voltage of the generator terminal, I know that what also would be the voltage of phase B and phase C. But when the generator is operating in an unbalanced mode, the voltage magnitude at phase A, phase B and phase C, they will be different. I mean, they will not be equal. So then therefore, when we are talking about the pre-specified voltage magnitude, are we talking about three different voltage magnitudes corresponding to phase A, phase B and phase C? Now, if we are talking about three different voltage magnitudes at each of these terminal, so then therefore for M generators, we will have 3M quantities, but we have just now said for every generator there is only pre-specified voltage magnitude, that is essentially Vi specified. It is only a single quantity. Why we are only pre-specifying a single quantity? Because of this fact that a generator has got only one field winding and the generator tries to control, or rather I should say that any generator tries to maintain the voltage magnitude at its terminal by varying the field current in the field winding. Because it has got only one field winding, so by varying the current in that single field winding, it can only control one single voltage magnitude. It cannot really control three different voltage magnitudes simultaneously by using only one field current, right? So, because of this fact that the generator has got only one field winding, so it can only control only one voltage magnitude. So, as a result, although at the generator terminal the three phase voltages are not equal to each other, we can only specify only one single quantity, which would be essentially a function of all these three phase voltage magnitudes, right? So, which would be basically a kind of some kind of combination of this all these three voltage magnitudes. So, there can be different types of functions. So, what I have is, so then therefore, what I say is that VIP would be some function Fi of some function of VIA, VIB, VIC. Some function Fi, it is some function. And this function takes these three values and gives only one single quantity. Usually what we take it the most conveniently, we take it VIP is just the average of VIA plus VIB. So, we just take the function, the simplest possible function, that this is just the average of these three voltage magnitudes. Of course, there can be any other function. I mean, I can take, let's say, Vi square plus VIB square plus VIB square, square root or mod or whatever it is. But usually this is the most logical one and we usually take this. So, we will go with this expression. So, this is my expression number 6. Let us say that PGI is equation number 6. So, I say that this is my equation number 7. So, this is for all VI, I think it is specified. So, this is not P, this is not P, this is VI specified, this is VI specified. So, VI specified is some function of VIA, VIB, VIC. Usually, we take it as the average of these three voltages. So, then therefore, so these are the equations. So, now to recapitulate my unknown voltage vectors. So, unknown vector x, let us say that unknown vector x. So, unknown vector x, I say that this is v theta, then v internal and theta internal, right? So I would say that T, this is T, this is transpose, right? So it would be an 6n plus 2m minus 1 cross 1 vector. What is Vt? So this has got 3n cross 1. So it is actually now 1 cross 3n. This is now 1 cross 3n minus 1. This is 1 cross m, and this is 1 cross m, right? So T. So then therefore I can write down that x, I can simply write down as something like this in our work, that or rather unknown vector capital X. So this is capital X. Capital X, I can write it down like this: V theta V int theta int. Right? So we can also write it in the same fashion. So this is 6n plus 2m minus 1. And my known vectors, or rather the specified vectors, that is the, let's say, m vector, that we say as that this is like this. So P specified, Q specified, P gen, V specified. So it is basically P specified. So M vector, we can say that this is P specified, Q specified, P specified, Q specified, then P gen, then V specified, and then V specified. So this is also a 6n plus 2n minus 1 vector. So these are my unknown quantities given by vector x, unknown vector. This is the known vector. This is the composite known vector. And this is the composite unknown vector x. So I have got this composite known vector, or I have got this composite known vector m. I have got this composite unknown vector x. And we have also looked into the equations relating vector x and m. So now we are in a position of solving these equations. So this we will start from the next lecture. Thank you.